Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discuss about one important problem that has asked in the previous examination. Okay, so this question is asked in the 2022 June-July question paper. So this is the second question from short answers. Okay, find the relative error of a function small u is equal to 5 into x into y square by z cube at x is equal to y is equal to z is equal to 1 when the errors in each of x, y, z is 0.001. Okay, so this is the question. So, we question ni baga observe cheste. So, we have to find out the relative error. Here, we have one function u. U is equal to 5x into y square by z cube. That function defined in three variables x, y and z. Okay, so now see the solution of this question. First of all, so I am taking u is equal to f of x comma y comma z be a function given as u is equal to 5x y square by z cube. Original ga ee function ni manam ila define chestam in general formula. To whenever we are going to derive the general error formula, so this function we can take in this format: u is equal to f of x comma y. Okay, so what is that meaning? The given function defined in three variables x, y, z. Okay, so therefore that three variable function in our problem given as u is equal to 5x y square by z cube. Okay, so that is taken as equation number 1. So at the same time in the given problem they also gave that x is equal to y is equal to z is equal to 1. Okay, so x is equal to y is equal to z is equal to 1. So that means those all values are equal, same. Okay, then the errors of x comma y comma z, we can take it as delta x, delta y and delta z. Okay, so respectively for x, delta x is the error, and for y, delta y is the error, for z, delta z is the error. From the given data, so you can write delta x is equal to delta y is equal to delta z is equal to 0.001. So that is only from the given statement only we can clearly write that one. Okay, so you can also make a box for this one. To find the relative error, now our aim is we have to find out the relative error of the given equation number 1. To find the relative error of the equation 1, first of all we have to find out the normal error. Okay, first we have to find out the error of the given function. First we have to find out the error, then after we have to go to the relative error. Okay, to find the error of the given function, so we have one formula, that is general error formula. That is general error formula is given by del u is equal to, or delta u is equal to dou u by dou x into delta x plus dou u by dou y into delta y plus dou u by dou z into delta z. So what is that meaning? So for the given equation number 1, you have to do the partial derivation with respect to x, you have to do the partial derivation with respect to y and with respect to z. So now we took that error equation as equation number 2. Okay, so therefore, so now by seeing that equation number 2, what we can conclude that, so first of all we have to find out the partial derivative of the given equation number 1 with respect to x and y and z. So first if you find out the partial derivative of u, so what you have, u is equal to 5x y square by z cube is the given function. For this function, if you apply the partial derivative, okay, so dou u by dou x with respect to x, then only x term only you have to partial derivative. In the first semester, second semester, you only studied these types of problems only. Okay, so you have to apply the partial derivative with respect to x only. Remaining terms will remain as a constant. Okay, remaining x, y and constants will remaining as a constant only. So therefore dou u by dou x is equal to, for x you will get 1. Okay, for y into 1 square, so z cube. Okay, y square, z cube, 5, those all comes under constants when you apply the partial derivative with respect to x. So this is the partial derivative of the given function with respect to x. Next, partial derivative of the given function with respect to y is, okay, so y square is there. So for y square, 2y is the derivative. Okay, 2 into y is the derivative, and here you have 5 into x. Okay, 5 into 2, 10. 10 into x into y by z cube. Only we are applying for y only. Okay, so remaining terms will be constant. So next, with respect to z, you will get that 5x y square by, here z cube you have. Z cube is nothing but z power minus 3. Z power minus 3 means minus 3 into z power minus 3 minus 1. So therefore minus 3 into z power minus 4. Okay, so in beginning we have 5x y square, and if with this 5 if you multiply with 3, okay, so therefore minus 15 xy square by z power minus 4, you will get is z power 4. Okay, so in this format you can get the partial derivative of the x, y and z. So after getting the partial derivative, substitute these three values in equation number 2. Okay, so therefore now substituting dou u by dou x, dou u by dou y and dou u by dou z values in equation number 2, then we get that the error delta of u is equal to 5y square z cube into delta x plus 10 into xy z cube delta y, and this one is the partial derivative of the dou u by dou z minus 15xy square by z power 4 into del z. After substitution of these values, so here you need to know that here we have the error values. Sometimes this error value may be positive or negative, but to get the error value, okay, so we have to apply the magnitude of the given function. That is only in the words format clearly mention you. Here the error delta x, delta y, delta z may be positive, negative, okay, for some cases. Hence we take the absolute values of the terms on RHS. In this problem we have positive error. In some cases if you get the negative errors, then you will get that to avoid the difficulty in simplification, so we are applying that the magnitude. That magnitude is nothing but mod values for the given error value. So therefore for RHS, so therefore whenever you apply the magnitude, then LHS also will become maximum. LHS acquires maximum value. So that's why I am writing delta U maximum is equal to, maximum is nothing but it gets the only positive values only. So that's why. So therefore mod of 5x square by z cube into delta x plus mod of 10xy by z cube into delta y plus 15 mod of 15xy square z power 4 delta z. Okay, why? Because actually minus 15 is there. When you apply the mod, it will become plus 15. Okay, so since from the statement of the problem we have x is equal to y is equal to z is equal to 1 and delta x, delta y, delta z is equal to 0.01. Apply these two values. Okay, substitute these two values in the above equation, then you will get the maximum value of the error of u, that is delta of u maximum is equal to 5 into y square means y is equal to 1. 1 square by z cube means 1 cube into this one is the delta x value, and 10 into xy by z cube. Okay, so this one is the delta y value, and 15 into x y square by z power 4 into delta z value. So x equal to y is equal to z is equal to 1 we are applying, and delta x, delta y, delta z we are applying as 0.001. Okay, so if you simplify the above equation, you will get the RHS as 0.03. Okay, so that is the error in capital U. What is the error here? Original value of capital U is nothing but, for example, if you have capital U is equal to 5x y square by z cube. This is the original equation. ఈ original equation లో x is equal to y, z is equal to 1 దగ్గర మీరు వాల్యూ సబ్స్టిట్యూట్ చేశారు అనుకోండి, మీకు ఎంత వస్తుంది? 5 into 1 into 1 by 1 వస్తుంది. మీకు ఎంత వస్తుంది? 5. u is equal to 5 is the original value, true value. ఇక్కడ వచ్చింది ఏంటంటే మీకు ఎర్రర్ వాల్యూ. సో దేర్ ఫోర్ 5 అనేది ఒరిజినల్ వాల్యూ. సో ఇక్కడ డెల్టా ఆఫ్ u is the error value, so that is 0.03. so therefore the error of u is 0.03. error of u is equal to 0.03. so after finding the error of the given function, now directly you can apply the relative error. So the relative error of u is given as e suffix r maximum is equal to delta u of maximum by u. సో ఇక్కడ మీకు ఒక డౌట్ రావచ్చు. ఓకే, సో రిలేటివ్ ఎర్రర్ ని ఫైండ్ అవుట్ చేసేటప్పుడు ఈ ప్రాసెస్ అంతా ఎందుకు చేయాలి? ఓకే, సో మనకి ఇక్కడ ప్రాబ్లం లో ఏమని అడిగాడు అని చెప్పేస్తే ప్రాబ్లం లోనే రిలేటివ్ ఎర్రర్ అడిగారు. రిలేటివ్ ఎర్రర్ అంటే మనకు రేషియో అప్లై చేస్తాం. రేషియో అప్లై చేయాలంటే ఫస్ట్ మనం అబ్సల్యూట్ ఎర్రర్ ని ఫైండ్ అవుట్ చేయాలి. రిలేటివ్ ఎర్రర్ అంటే ఏంటి? మనం అబ్సల్యూట్ ఎర్రర్ ని ఫైండ్ అవుట్ చేయకుండా మనము రిలేటివ్ ఎర్రర్ ని ఫైండ్ అవుట్ చేయలేం. సో దేర్ ఫోర్, సో దట్స్ వై ఓన్లీ ఫస్ట్ ఆఫ్ ఆల్ వి derived that absolute error of small u. So therefore del u by u. What is the del u value? 0.03. And what is the u? ఇక్కడ u అనేది ఏంటంటే at x is equal to y is equal to z is equal to 1. దాని ఒరిజినల్ వాల్యూ అది. Okay, so therefore 5. Okay, so 0.03 by 5 you will get 0.006. That is the relative error. ఫస్ట్ ప్రాబ్లమ్ లో మనం అబ్సల్యూట్ ఎర్రర్ కి ఎగ్జాంపుల్ చూసాం. ఈ లెక్చర్ లో రిలేటివ్ ఎర్రర్ కి ఎగ్జాంపుల్ చూసాం. సో ఈ రెండు లెక్చర్స్ మీరు అబ్జర్వ్ చేస్తే యూ విల్ గెట్ ద క్లారిటీ వాట్ ఈస్ ద అబ్సల్యూట్ ఎర్రర్ అండ్ వాట్ ఈస్ ద రిలేటివ్ ఎర్రర్ అండ్ హౌ యూ కెన్ అప్లై ద ప్రాబ్లమ్స్ బేస్డ్ ఆన్ దెమ్. ఓకే, సో ఇన్ ద ఎగ్జామినేషన్ పర్పస్ ఓన్లీ దీస్ టైప్స్ ఆఫ్ క్వశ్చన్స్ ప్లేస్ కీ రోల్. ఇదే కాదు, మీకు ఎగ్జామ్ లో ఫంక్షన్ ని చేంజ్ చేసి ఇవ్వచ్చు. XYZ లోనే 5xy² కాకుండా వేరే ఫంక్షన్ అడగొచ్చు, ఆల్జీబ్రిక్ ఫంక్షన్ ని. x, y, z is equal to 0.1 అడగొచ్చు, 0.5 అడగొచ్చు. వాల్యూస్ చేంజెస్ అడిగినా కూడా సో యూ హ్యావ్ టు ఎయిదర్ రిలేటివ్ ఎర్రర్ ఫైండ్ అవుట్ చేయమన్నా, పర్సెంటేజ్ ఎర్రర్ ఫైండ్ అవుట్ చేయమన్నా మీరు ఈ ఫార్మాట్ లోనే చేయండి. ఇది మనకి ఇప్పుడు రిలేటివ్ ఎర్రర్ 0.006 వచ్చింది. దీనికి పర్సెంటేజ్ ఎర్రర్ ఫైండ్ అవుట్ ఎలా ఫైండ్ అవుట్ చేస్తాం? వచ్చిన రిలేటివ్ ఎర్రర్ కి ఇంటూ 100 చేస్తాం. ఇంటూ 100 చేస్తే మీకు వచ్చే వాల్యూ ఏంటంటే మనము పర్సెంటేజ్ ఎర్రర్ అని చెప్పేస్తాం. ఈ ఫార్మాట్ లో త్రీ ఎర్రర్స్ వాడి ఏది అడిగినా కూడా మీరు ఈ ఫార్మాట్ లో ప్రాబ్లం కి ఫార్ములాస్ లో అప్లై చేసుకుంటూ సాల్వ్ చేయాలి. ఓకే, అందుకని నేను ఏమని చెప్తానంటే డెఫినేషన్స్ ఆర్ ద బేస్ ఆఫ్ ఎనీ సబ్జెక్ట్స్. మ్యాథమెటిక్స్ లో ఫార్ములాస్, డెఫినేషన్స్ ఆర్ ద బేస్. అవి పర్ఫెక్ట్ గా ఉన్నారనుకోండి, యూ కెన్ సాల్వ్ ద ఎనీ టైప్ ఆఫ్ ద ప్రాబ్లమ్. సో ఎంటైర్ న్యూమరికల్ అనాలిసిస్ deals with the different types of methods. Okay, so further in upcoming videos you will know what those are. Okay, so that's why only make a perfect practice, prepare well. I hope you understood this problem very well. In the next lecture we are coming with another interesting topic. So until bye, thank you.